we are going to discuss a very important topic in the quadratic equation, that is location of roots, right? Location of roots. Okay, so basically in the examination, right, they give a quadratic equation to you. In the quadratic equation, there are some unknown quantities are there, and they put a certain condition on the roots of the equation with a number. Maybe number is one number, can be two number, right? So from the different cases, we understand that how the things are going on. Okay. So before starting this topic, I am giving you just a small introduction to the graph of a quadratic polynomial, right? So y equal to ax square plus bx plus c. Basically, this is a quadratic polynomial, right? Geometrical shape of a quadratic polynomial is a parabola, right? So there is two possibility on a. First is greater than 0, second is less than 0. For a greater than 0, we get a upward parabola, and for a less than 0, we get a downward parabola. Second thing, if this is the x-axis, so where the x-axis cuts the graph, at that point we find the roots of this quadratic polynomial. Similarly, this is the x-axis, so this point and this point is basically the roots of this quadratic polynomial, right? First thing is clear. Now another point is this, to get this is the bottom of this graph. Generally we say vertex. Okay, so coordinate of this vertex is minus b by 2a comma minus d by 4a, and this is the topmost point of this graph. So coordinate of this point is minus b by 2a comma minus d by 4. Again one thing, here is the d. What is the meaning of d? D is the basically discriminant, that is b square minus 4ac, and this gives us the nature of the roots. If b square minus 4ac is greater than 0, we can say that roots are real and distinct. If I say d equal to 0, that means roots are real and equal. And if d is less than 0 and a, b, c are real numbers, then we can say that roots are imaginary and occurs in conjugate pair, right? So we have to knowledge about the two things. First, how to plot the basic of the graph. What is the case of upward parabola, what is the case of downward parabola, and how is the behavior of d. Okay, so from the different cases, we are going to understand that how we relate the roots of a quadratic equation with some numbers or number, right? So case 1, when both roots are greater than a number k, right? Fx equal to what? Fx equal to ax square plus bx plus c equal to 0. This is your quadratic equation, and both roots of this quadratic equation are greater than a number k. Okay, so look at it. First, according to condition, we will plot the graph. Okay, so I am supposing that a is greater than 0, so it should be an upward parabola. If both roots are there, that means x-axis cuts the graph at two distinct points. This make we also, this is the upward parabola, and this is the roots of this graph, and these both roots are greater than a number k, right? These both roots, look at it, this is alpha, this is beta, so both roots are greater than a number k. In this case also, the roots are equal, real and equal, and these roots are greater than number k, right? For a less than 0, what can be there? Graph will look like this way, or graph will look like this way. Okay, and this is the number k. Okay, now look at here. For our convenience, what I am doing, I am making this a positive. If in the question a is positive given there, Okay, it's okay. But if it's a is negative, by multiplying the both sides with minus sign, I can make the a positive. What the benefit I will get? So when I will make this a positive, I have to not deal with this case. Okay, I will deal only with this case. Okay, so very first thing what I am doing, I am make a positive. Okay, the very first thing. Now to describe this graph, I am writing some inequalities in the form of algebraic form, right? So very first thing is here, both roots are there. Okay, both roots are there. The roots can be distinct or can be equal, right? So very first thing is what? D is greater than or equal to 0. Now I am saying that this condition is sufficient to describe this graph completely. This condition is sufficient. So look at it. If someone saying that, look at this case. This is alpha, this is beta, and let's suppose this number is k is here. Okay. In this case, also d is greater than 0. Right. So if I am writing only this condition, I am including this one, but as well as I am including this case also. There can be other possibilities also. Right. I am just giving a basic example that how d greater than equal to 0 is not sufficient to specify this graph only. Right. So now I am going to think about the other condition. If I look at here, your roots alpha and beta is greater than number k, and the one important point is that look at this vertex. What the coordinate of the vertex? That is minus b by 2a, comma minus d by 4a, right? So the x coordinate of the vertex is what? Greater than number k here, right? So your minus b by 2a is greater than k. Okay. Now these both conditions are sufficient. So look at in this case. Let's suppose that I am writing k here, and this is the vertex minus b by 2a, comma minus d by 4a. Right, corresponding to this one is minus b by 2. In this case also, your minus b by 2a is greater than k. Right. So if I am writing these two conditions, this is already included. These two conditions will not specify this graph uniquely. Uniquely, that means if I say that these two conditions are there, so these two conditions, okay, follows here, but at the same time it follows other cases also. For example, I have said this. Okay, so now I am going to discuss about the third condition. So look at here, if I say what the value of fk here, if positive or negative, fk. So if I draw a vertical line here, it cuts the graph somehow here. That means it cuts the graph above the what? X-axis. Above the x-axis, y is positive. So I say that fk is what? Greater than 0. But in this case, fk is less than 0. So if I am applying this condition, this one is eliminated. Right? Okay. So these three conditions are required to describe this graph uniquely. Okay. So when you have the question that both roots of a are greater than a number k in the quadratic equation fx equal to ax square plus bx plus c equal to 0, then apply these three conditions, solve them, and in the last take the intersection of all these results of all these three cases, and you will get the final answer, right? So from a question we understood, we practice this concept, right? So I am taking a question. Okay, so I am writing a question here. Find the value of d for which both roots of equation x square minus 6 dx plus 2 minus 2d plus 9d square equal to 0 are greater than 3. Okay, this is the question. So first of all, according to question, we are going to draw the graph. Okay, so according to the question, the both roots are greater than number 3. So our graph look like this way. This is the 3 and both roots, this is the root, this is the position of root, right? So both roots are greater than number 3. Okay, so first of all, the first condition is what? D should be greater than or equal to 0. So what is D here? B square minus 4AC, that is 36 D square minus 4 into 1 into 2 minus 2D plus 9D square, and that is what? Greater than or equal to 0. Let's simplify this one. So 36D square minus 8 and minus minus plus 8D and minus 36D square greater than or equal to 0, right? 36D square and this is minus 36D square cancel out. If I take the 8 common here, this is D minus 1 greater than or equal to 0. So from there I can say D is greater than or equal to 1. Done. Now the second condition is what? Minus B by 2A. Minus B by 2A should be greater than K. So what the minus B by 2A? Look at here. This is the coefficient of x square is 1, that is A. This is your B and this is your C. Done. So minus B by 2, that is 6D upon what? 2A, that is 2 greater than what? 3. So D is greater than 1. Okay. This is the second condition. Now what is the third one? Third one is what? Your f of k is greater than 0. So what the f of k means? F of 3 is greater than 0. This is your fx, right? This is your basically fx. So if I put the 3 here, 3 square 9 minus 18d plus 2 minus 2d plus 9d square is what? Greater than 0. Let's simplify this one. So this will be 9d square, okay, minus 20d and plus 11 greater than 0. Now I am going to solve this inequality. I am going to use the vehicle. Okay, so I am doing the linear factorization here. Okay, so 9d square minus 11d minus 9d plus 11 greater than 0. Take the d common here, so it's 9d minus 11. Take the minus 1 common here, so it's 9d minus 11 greater than 0 here. So this is 9d minus 11 and d minus 1 is greater than 0. Okay, now put this linear factor equal to 0. So after putting this 0, I am getting 11 by 9. This is 11 by 9, and after putting this one equal to 0, I will get the 1. Okay, right? Now all the coefficients are positive here, so I will put the plus sign here. 9d minus 1, the power of this one is odd, so I will change the sign from plus to minus, and again the power is odd here, so I will change the sign from minus to plus. Okay, greater than 0, so I will take the positive interval, that is from there your d belongs to minus infinity to 1 union 11 by 9 to infinity. Okay, right? These are the three cases. After solving these three cases, what I will do? I will take the intersection. So it's very clear that Okay, for intersection you can use the number line. So look at here. The first case is what? D is greater than or equal to 1. Let's suppose this is the 1 here. So D is greater than or equal to 1 here. Okay. Second one is what? Your D belongs to greater than 1. So D belongs to greater than 1. And third is minus infinity to 1. Minus infinity to 1. And 11 by 9 to infinity. So this is 11 by 9 here. So 11 by 9 to infinity. So if I take the intersection of all these three cases, what I will get? D is element of 11 by 9 to infinity. How will take the intersection? Just superimpose all these lines. Right. What the common portion? So common portion will be what? 11 by 9 to infinity. So this is our result. Okay. This is our final answer. Okay. So in this question, basically, in this type of question, basically we deal with three things. First is D, discriminant. What the discriminant is there? Okay. Second thing, the value of a specified number with respect to minus b by 2a position. That means we will check this minus b by 2 is greater than k or minus b by 2 is less than k. Okay. Third thing is that whatever the specified number there, I will put the specified number in the fx and I will check this is the positive or negative. Later on, when we will discuss the other cases, my focus is on three things. Okay. So I am going to take the case number second. So case number second is what? When both roots are less than a number k, okay, in equation ax square plus bx plus c equal to 0. Okay, so first thing I am making the a positive. Okay, so the very first thing is what? Make a positive. Okay, now look at here. Okay, we draw the graph. So what the graph looks like this. Right, this is the roots of this quadratic polynomial. Right, this is the roots of this quadratic polynomial, and these both roots are less than number k. Okay, now I am going to write the condition. So very first condition is about d. So d should be what? Greater than or equal to 0. Right. Second thing is what? Position of minus b by 2a with respect to k. So look at here. This is the coordinate minus b by 2a comma minus d by 4a. So obviously the x coordinate of this point is behind the k. That means your minus b by 2a is what? Less than k. And what about third thing? Third thing is the value of fk is positive or negative, right? So if I draw a vertical line here, it will cut the graph above the x-axis, right? So your fk is what? Greater than 0. These three things. Similarly, in the previous question, like a question is given there, then apply these three conditions, and whatever the results are coming, take the intersection, and you will get the final answer. Right? So case 2 is somehow similar of case 1. Only thing is what? Where the roots are greater than, and here the roots are lesser than. Okay. Sometimes in the question they ask, find the value of something when roots are positive. Both roots are positive. That means what? Both roots are greater than number 0. Okay. So similarly, in the previous question, in place of k, if you put the k equal to 0, you will get the both roots are positive. Okay. In this question, if you take the, if like question is saying that both roots are negative, that means if you put the k equal to 0, in this case, you will get the both roots are negative. That means both roots are less than 0. right? So sometimes they ask the both roots are positive, both roots are negative, so you can relate with the location of roots. Okay, this is the case number 2. Now I am going to discuss the case number 3, third case. Now I am saying that both roots are either side of a number k in equation ax square plus bx plus c equal to 0. Okay, so the first, according to the condition, I will draw the graph. So very first thing what I am doing, I am making the a positive. Make a positive. Okay, right. So when I take the a positive, like I have not to deal with the a negative case. Okay, so I am making the a positive here. Now this type of graph looks like. So this is your roots alpha and beta, right? This is the roots alpha and beta, and these roots are the either side of a number k. Okay. Now the very first thing is what about d? If I like the look at the d is what? Greater than 0. That means roots are real and distinct. Okay. Second thing, the position of minus b by 2a with respect to this number k. Right? So look at here. If I say this is the vertex, let's say I am writing this k here, and this is the vertex minus b by 2a comma minus d by 4. Now look at here. In this case, minus b by 2a is greater than k. Okay, this k is between the alpha and beta. If I put the k here, now in this case your k is greater than minus b by 2. Still, this graph matching with our condition. Both roots are either side of the roots. Both roots are either side of the number k. Right? Or it can say that a number k lies between the roots alpha and beta. So I cannot relate the minus b by 2a position with respect to k in this graph. Okay, so I am not going to discuss about the second case. Third thing is, what is the value of fk? So if I draw a vertical line here, it cuts the graph below the x-axis. That means y is negative here, right? So fk is what? Less than 0. Fk is less than 0. Done? Now listen me carefully. If I say that fk is less than 0, that means for a value k, your graph is going down with down below the x-axis. Okay, so look at it. You have upward parabola, right? So in upward parabola, both wings are going to infinity, right? Now look at it. One wing is coming like this way. To go down below the x-axis, it crosses the x-axis. We get the one root. Now it's coming down, and after that is going up, and when again it cuts the x-axis. Okay, so if I say that there is an upward parabola, and this upward parabola for a value k, this upward parabola giving me a negative result. Okay, that means automatically it should have a two roots. It should have two roots automatically. Right? So that means if you are writing this fk less than 0 for an upward parabola, then there is no need to write this one, d greater than 0. What is the meaning of that? Let's suppose that a question is given there. Okay, both roots of a quadratic equation lies between a number like some 3 lies between the roots of quadratic equation. This is this. Okay, you are writing a d greater than 0 there. Okay, after solving this, we are getting a result. Then you are writing fk less than 0. After solving, you are getting a result. Okay, when you take the intersection of these two cases, you will get the same result when you solve fk less than 0. Okay, so is no need of this, no need of this. Okay, so this is the only sufficient condition to describe this graph completely. I earlier said to you, focus on three things. First thing is discriminant, second thing is minus b by 2a with respect to k, and third thing is what the value of k in fx, right? So based on this concept, we'll solve a question. So question is that find in for which one root is positive and other root is negative for minus x square minus 3a minus 2 into x plus a square plus 1 equal to 0. This is our question, right? Positive and other root is negative. What is the meaning of this? That means 0 lies between the both roots. Okay, if 0 lies between the both roots, that means one side you will get the positive roots and other side you will get the negative. Okay, so now one thing, look at here, the coefficient of x square is negative here. So what I am doing, I am multiplying with minus sign here. So I am writing this one as x square plus 3a minus 2 into x and minus a square plus 1 equal to 0. I am making the coefficient of x square positive by multiplying the minus sign. Now d greater than 0, no need to write this one. We cannot relate the minus b by 2a with respect to k. Okay, look at it. Focus on these three things because in the examination it is very difficult to memorize the condition. Right? First we have to draw the graph and then according to graph we have to think about the three things. Okay, so according to graph, like graph looks like this way. One root is positive, one root is negative. So d is greater than 0. Second condition, we cannot relate the minus b by 2a with respect to k. And the third thing is what? What the value of fk? K is 0 here. K equal to 0 here. Okay. So I am going to check the f of 0 and f of 0 should be what? Less than 0. Okay. So what the f of 0 here? If I put the 0, so if I put the 0 here, that means 0 plus 0 minus a square plus 1 is what? Greater than 0. If I multiply with both minus side, so a square plus 1 is greater than 0. Okay. So a square plus 1 is greater than 0. So what is a here? A can be any real number. Right. This is a quadratic equation. Right. In terms of a and a square plus 1. That means if you put the a any numbers after square it will be positive and positive plus positive will be greater than 0. So a is a real number. Right. So I hope you understood this concept. Are you getting all these points? Okay. Now I am going to discuss about the case number 4. Case number 4 is what? When both roots lies between the number k1 and k2. I am saying that k1 is less than k2. K1 is less than k2. Okay. In quadratic equation, ax square plus bx plus c equal to 0. This is our case. So very first thing what I am doing, I am making the a positive. possible. Okay. Now I am going to draw the graph. How the graph looks like. So first, this is a number line. First I am writing k1. This is k1 and this is k2. k1 is less than k2, and is saying that both roots lies between the number k1 and k2. So this graph is look like this way, or it can be looks like this way also. It can be look like this way also. Okay. Now according to this graph, I am going to write the conditions. Okay. Look at it. So the very first thing is what? Discriminant, right? So this d is what? Look at the graph. You are getting, in one case you are getting the real and distinct root. That means d is greater than 0. Another case you are getting also d equal to 0. So d can be greater than 0 or can be equal to 0. Okay. Second thing, position of minus b by 2a with respect to k1 and k2. So this is the vertex minus b by 2a comma minus d by 4a, right? So if I look at now minus b by 2a, so minus b by 2a is what? Greater than k1 here and less than k2. Okay. Third thing, what is third thing? Value of fk1 and fk2. So look at it. F of k1 is what? Graph is, if I draw a vertical line here, it will cut the graph above the x-axis. If I draw a vertical line here, it will cut the graph above the x-axis, right? So what about fk1? Fk1 is greater than 0 and fk2 is also greater than 0. Now one student is saying that fk1 is greater than 0. Okay, fine. fk2 is greater than 0. So in place of these two inequality, can I write fk1 into f of k2 is greater than 0? Can I write? So look at it. If f of k1 is greater than 0, f of k2 is greater than 0, obviously fk1 into f of k2 is greater than 0. No issue. But if I am writing this one, what I am doing wrong? If k1 is negative, if a k2 is negative, still product is positive. That means if you are writing this case follow, but at the same times fk1 less than 0 and fk2 less than 0 can be also followed. That means if I write this one, I am writing the extra cases. Okay, so I will avoid this one. इसको avoid करें, right? Now I am taking a question, and from this a question we will understand this concept. Okay, so I am writing a question. Okay, so this question is that if alpha comma beta is element of 6 to 1, then find k for which x square plus 2 into k minus 3 into x plus 9 equal to 0 has roots alpha beta. Okay, so according to question, first I will plot the graph. Okay, a is positive here, no issue. So look at this. Alpha and beta belongs to minus 6 to 1. So minus 6 is there and 1 is there, and alpha and beta belongs to minus 6 to 1. Right? The graph can look like this also. When both alpha and beta are equal, can be equal, no issue. That means what? Both roots alpha and beta lies between what? Minus 6 to 1. Okay. So what we will discuss first? What about the d? What about the d? D is what? Greater than or equal to 0. Now I am going to solve this condition, right? So D, that is what? B square minus, D is what? Basically B square minus 4AC. So what the B square minus 4AC here? 2 square 4 and that is K minus 3 whole square. B square minus 4AC. It is 4 into 1 into, and what does C here? C is 9 here and is greater than or equal to 0. Done? Now I am going to simplify this one. So 4, this is K square minus 6K plus 9, right? And this is minus 36 and is greater than or equal to 0. Done? Now multiply this one. So 4K square minus 24K plus 36 minus 36 is greater than or equal to 0. 36 cancel out there. Take the K common here. 4K common here. So this will be K minus 6 greater than or equal to 0. That is K into K minus 6 is greater than or equal to 0. Okay. Now I am going to solve this inequality. So this factor will be 0 at 0. This factor will be 0 at what? 6. Right? All the coefficients are positive here. So I will start with plus sign. Plus. The power is odd here. So this is minus. Again the power is odd. So it's plus. And I am talking about what? Greater than 0. So K belongs to minus infinity to 0 union what? Close interval here. Because equality is also mentioned, so I will take the close interval. So this is the value of K here, what? Minus infinity to 0 union 6 to infinity. This is the first condition. D is greater than or equal to 0. Okay. Now I am going to write about the second condition. What the second condition is there? Look at it. What the second condition? Here minus b by 2a. What the second condition? Minus b by 2a is between what? Minus 6 to 1. So what the minus b by 2a? Minus b by 2a, that is minus 2 into K minus 3 divided by minus b by 2 into 1. This is minus b by 2a. And this is greater than minus 6 and less than what? 1. 2 and 2 is cancelled out from there. Multiply with minus sign. So this will become plus 6. Inequality sign get reverse. And this is K minus 3. And again reverse. And this is minus 1. Done? Right? Now add plus 3. So this is K. This will be what? Minus 1 plus 3, 2. And this will be what? 9. That means K is element of what? 2 to 9. I hope you are getting this point. Okay. Now the third point. Third point is what? Third point. Look at here. Third one is what? Here f of minus 6 should be greater than 0. So what is f of minus 6 here? If I put the minus 6 here, so it's 36 minus 12 k minus 3 and plus 9 is greater than what? 0. Let's simplify this one. So it's 36 minus 12k and minus plus 36 plus 9 greater than 0. That means what? 72 plus 9. 81 minus 12k greater than 0. So k is less than 81 by what? 12. That is what? Less than what? 27 by 4. 27 by 4. Right. Okay. Now, this is A part. But the B part is there. F of 1. F of 1. F of 1 is also what? Greater than 1. Right? F of k1 greater than 0. F of k2 greater than 0. So I have solved f of k1 greater than 0. Right? Now I am going to solve f of k2 greater than 0. That is f of 1 is what? Greater than 0. What is the f of 1? So 1 plus 2 into k minus 3 into 1 plus 9 what? Greater than 0. That is 1 plus 2k minus 6 plus 9 greater than 0. This is This is what? 9 plus 1 10 minus 6 4. That is 2k plus 4 greater than 0. That is k is greater than minus 2. Now you have the 4 inequalities. First one is this one. This is the first one. This is the second. This is the third. Right? And this is the fourth. Okay. So from these 4 results, what I am going to do? I am going to take the intersection of all these 4 cases, and finally I will get the result. Okay. So if you take the intersection of all these 4 cases, what you will get? This value from 6 to infinity. For the 6 to infinity, this value is minus greater than minus 2. That means from this both to 6 to infinity common. From this case 6 to 9 common, and from this case less than 27 by 4. That means your final result is what? K is element of 6 to 27 by 4. Right? It is very simple, right? On the number line, draw the every cases and take the superimpose, and after whatever the common portion are there, this is the final value of K. Okay, close interval is 6 to 27 by 4. So I hope you understand this concept. We are getting everything. In this location of root topic, like first of all thing, whatever the question is there, according to question, first draw the graph. And after drawing the graph, think about the 3 things. D, position of minus b by 2a with respect to k, and what the value of fk1, fk2, whatever the number mentioned here, according to what the value you are getting, positive value or negative value. So this is the case number 4. Okay. Now I am moving to the next case, case number 5. So case 5. When both roots are either side, both roots, may I say alpha and beta are the roots, either side of numbers k1 and k2, ठीक है, 2 नंबर लेते हैं, right? k1 and k2, and I am saying that what? k1 is what? Less than k2. k1 is less than k2. In quadratic equation, ax square plus bx plus c equal to 0. So according to condition, first what I will do? I will plot the graph. Okay. So look at here. First I am marking k1 and k2. So this is k1 and k2, and both roots are either side of the number. Let's say I am saying that alpha is less than beta here. Alpha is less than beta. So either side of the number k1 and k2, this is alpha and this is beta. Okay, and the graph is going like this way. Okay, right? Okay, now according to graph I am going to write the condition. So very first condition is what? D is what? Greater than 0. D is greater than 0. There is no possibility that D can be equal to 0. Right? Because if you make the D equal to 0, right, k1 and k2 will be only one side of the graph. Sorry, alpha and beta will be the only one side of the graph. So D is greater than 0. Right? Now the second condition, minus b by 2a with respect to k1 and k2. So look at here. If I am going to write this is a minus b by 2a. So in this case, minus b by 2a is what? In this case, it's looking between k1 and k2. But if I take the k1 here and k2 here, minus b by 2a is now greater than k1 and k2. That means what is the things are there? We cannot relate the minus b by 2a with respect to k1 and k2. So no need to write the second condition. Now about what about third condition? So f of k1 is what here? F of k1 is, if I draw a vertical line here, it's going to cut the graph below the x-axis. That means you are getting the fk1 negative. So f of k1 is what? Less than 0. Similarly, fourth one is what? F of k2. What about f of k2? F of k2 is again what? Less than 0. If I draw a vertical line here, it cuts the graph below the x-axis. Done? So f of k2 is again less than 0. Right? I cannot combine this case to write the f of k1 into f of k2 what? Greater than 0. Is negative, so product is positive, okay, but at the same time fk1 can be positive and fk2 can be positive, right? So I will write these two cases separately. I am not going to combine this one, right? Avoid this one. This is wrong. We will discuss the last case, case number 6. When exactly one root lies between k1 and k2. I am saying that what? K1 is less than k2. In quadratic equation, ax square plus bx plus c equal to 0. So the very first thing, according to the graph, according to the condition, I will make the graph, right? So the first thing is what? I am making the a positive here. Make a positive. Right? Now this is k1 and this is k2, and your graph can be look like this way, or this is k1, this is k2, and your graph can be look like this way. Okay. Similarly, this can be also be a possibility. And this can also be a possibility. Okay. Look at here. Exactly one root lies between the k1 and k2, or I say k1 belongs, that means roots belongs to k1 and k2. Again here, exactly one root is lies between k1 and k2. Look at here. Here one root is passes through k1 and another root is between k1 and k2. Since at k1 I am putting the open here, so obviously I am not including the k1 here. That means still exactly one root lies between k1 and k2. And similarly at k2 I am putting the open, so still between k1 and k2 there is exactly one root. Okay. So first thing I am going to discuss about the what? D. Whatever discriminant is what? Greater than 0 here. Right? Second thing, what the position of minus b by 2a with respect to k1 and k2. So look at it. I cannot relate the position of minus b by 2a with respect to k1 and k2, because if I say that, look at here, this is k1, this is k2, and this is graph minus b by 2a here. In this case, your minus b by 2a is what? Less than k1, less than k2. But look at this one. If I say k2 is here, minus b by 2a is what? Greater than k1 and k2. That means we cannot relate the k1 and k2 with respect to minus b by 2a. So no need to write the second one. Okay. Now the third one is that what the value of f of k1, f of k2. So look at from the first one and second one, if k1 is what? If you draw a vertical line here, it will cut the graph above the x-axis. So f k1 is what? Greater than 0. And if I draw a vertical line here, so it will cut the graph below the x-axis. That means f of k2 is less than 0. From the second one, what I can write? F of k1 is what? Less than 0. F of k2 is what? If I draw a vertical line, that is greater than 0. From these two cases, what I can say? One is positive, another is negative. In this one is negative, other is positive. So if I combine, I can say f of k1 into f of k2 is what? Basically less than 0. Are you getting my point? Right. Here I can combine this, because if I less than 0, one should be positive, one should be negative. One is positive, one is negative. One is negative, other is positive. So here I can combine. Now one thing is important is that in a upward parabola, for some value of k1, if k1 is negative, or some value of k, if k is negative. So when a upward parabola is coming down, obviously it will go up and it will cut the x-axis at two distinct points. That means automatically I will get the two real and distinct roots. Right? So we have no need of this. Like in the previous case also you can write this, because in the previous case f k1 is less than 0 and f k2 is less than 0. So and I am dealing with the upward parabola case. Right? So in case of upward parabola, for some value of k, if f k is negative, automatically I will get the two real and distinct roots. Hope I am getting my point. So what the final is here? Finally I can say f of one thing is also there. Look at these two cases. In this case f k1 is positive, but at the same time f k1 is 0. In this case f k1 is positive, but f k2 is 0. Okay. So someone can say that f k1 into f of k2 can be equal to 0 also. I will agree with this point. So f of k1 into f of k2 can be less than or equal to 0. But look at one point. If I always include the equal to 0, at the some point this becomes also. K1 is there and K2 is there. No roots lies between K1 and K2. Then what the problem is here? If you have a question of exactly one root, first solve with f k1 into f k2 less than 0. From there you will get some result. And in this result, check the endpoints separately. Because if you are writing this one, okay, equal to 0 is included in this case, but equal to 0 is also included in this case also. So you cannot blindly write the f k1 into f of k2 is less than or equal to 0. At equal to 0, you should be careful. That means you have to deal the equal to 0 case separately. From a question, we understand this concept, how this works in the question. Okay? So a question is there. Find the set of value of m for which exactly one root of equation x square plus mx plus m square plus 6m equal to 0 lies between -2 to 0. Right? This is our question. So exactly one root lies between -2 to 0. So what the condition is there? F k1 into f k2 is less than 0 and it can be equal to 0, and I will check the equal to 0 case separately. So first I am solving the f k1 into f k2 is less than 0, right? So look at here. First I am writing f k1. F k1 is what? F minus 2. This is your fx. This is your fx. Right? So f minus 2 into f0, and it should be what? Less than 0. So put the minus 2 here. Minus 2 square 4 plus minus 2m, right? And this is plus 2 square 4 minus 12, right? And f of 0 is what? This is 0, this is 0, and this is m square plus 6m, and is what? Less than 0. Let's simplify this one. So 4 minus 12, that is what? Minus 8, and minus 8 plus 4, that is what? Minus 4. So if you take the minus 2 common from here, it will be m plus 2. From there, if you take the m common from here, is m plus 6 is what? Less than 0, right? Okay, fine. Now if you send this minus to this side, this will be m into m plus 2, m plus 6 is what? Greater than 0, right? Okay, now use the vehicle, draw a number line here. This factor will be 0 at where? M equal to 0, right? This is the m equal to 0 here. This factor will be 0 at m equal to minus 2. So let's say this is minus 2 here. And this factor will be 0 at minus 6. So this is minus 6 here. All coefficients of m is positive. This is positive, 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 right? So I will take the plus, then minus, then plus, and this minus. I will start with plus, and when I will get the odd power in the linear factor, I will change the sign. So at 0 is coming from this factor, and power is odd, so I am changing the sign. Similarly, minus 2 is coming from m plus 2, power is odd, so again I am changing the sign. And minus 6 is coming from m plus 6, again power is odd, so I will change the sign. Vehicle. Okay, for greater than 0, what I will take? I will take the positive interval, right? I will take the positive interval. So what the positive interval is there? M is belongs to minus 6 to minus 2 union 0 to infinity. Now look at here. This is the fk1 into fk2 is less than 0, for less than 0, right? For equal to 0, I will check the end points separately, right? Check end points of the interval separately. What is meaning of this? So for m equal to minus 6, I will put the m equal to minus 6 here. So this is 36 x square plus minus 6m plus 36 minus 36 equal to 0. 36 will be cancelled out. If I take the what the value of m here? M is minus 6. So this is x. Okay. So if I take the x common here, x minus 6 equal to 0. So I am getting x equal to 0 and x equal to 6, right? I am putting the m equal to minus 6. Where? In this equation, in fx. Okay. Now I am getting x equal to 0 and x equal to 6. So look at it. X equal to 0 is what? Roots. For m equal to what? Minus 6. Can 0 lies between this one? Minus 2 to 0? No. Can x equal to 6 lies between minus 2 to 0? No. That means for m equal to 0, there is no root between minus 2 to 0. Are you getting my point? I am putting m equal to minus 6. I am solving the equation. I am getting the two results. One is 0 and other is 6. And when I am checking this, is this root lies in this interval? Is the exactly one of this lies in this interval? So no. That means I am not going to include the minus 6. Are you getting my point? I am not going to include the minus 6. This point is clear? This point is clear? Now I will put the m equal to minus 2. For m equal to minus 2, what I am getting? 2 is x square. I am putting m equal to minus 2 here, right? So x square minus 2, yani minus 2x plus 2 square 4 and 6 minus 2, that is minus 12, okay, equal to 0. That is x square minus 2x minus 8 equal to 0. When I am going to solve this one, x square minus 4x plus 2x minus 8 equal to 0, right? If I take the x common here, I will get the x minus 4 plus 2 into x minus 4 equal to 0. So from there I will get x equal to 4, x equal to minus 2. Now look at it. X equal to 4 and x equal to minus 2. X equal to 4 lies between minus 2 to 0 or not? So no. X equal to minus 2 lies between minus 2 to 0 or not? So no. That means for m equal to minus 2, when we are solving the equation and what the roots we are getting, this root is not belongs to what? Minus 2 to 0. Exactly one root is not belong to minus 2 to 0. That means again I am not going to consider m equal to minus 2. Right? Now for m equal to 0. Okay. So look at it. For m equal to 0 I am checking. So for m equal to 0, what is there? X square. This will be 0, right? For m this is equal to 0, so x is equal to what? 0. X equal to 0. Okay. So x equal to 0. Is this any root between minus 2 to 0? So I will say no. Again I have no root is there. Are you getting my point? Are you getting my point? When I am putting m equal to 0, I am getting x square. This term will be 0. This term will be 0. So x square will be x equal to 0, and x equal to 0 is not lying between minus 2 to 0. That means m equal to minus 2, m equal to 0 is also not following the condition. So what will be the final answer? Final answer is what? M belongs to what? Minus 6 to minus 2 union 0 to infinity. What is the meaning of this? Let's suppose that for m I am solving for m equal to 0 and I am getting the answer, and that answer, exactly one answer lies between the minus 2 to 0, then I am going to include, otherwise I am not going to include this one. Right? So I hope you understand this concept. Thank you.